Welcome to our next video of generics. In the previous video, we looked at the introduction to generics and the why we have generics, a little bit of background of generics and some benefits. So we saw that generics ensures type safety, and as well as it streamlines the creation of general methods, classes, as well as the interfaces by ensuring that we don't use explicit casting to achieve that general implementation of our code. In this video, we'd like to look at the generic method. So a generic method has a type parameter. As we saw that we are able to come up with a generic class, generic method, or interfaces by having a type parameter. So generic method has a type parameter which is placed before the return type in the method. So here we're just showing you the general form of how we can create a generic method. So before the return type, we have a generic parameter that we specify. So we can now use this generic parameter or the parameters that are specified here in our function in a place of an maybe a data type. And what we place inside here, usually we use T, we use one letter, but you can have more than one letter, but we use one letter to differentiate it from maybe variables or constants. So we just have one letter, for example T, but other letters can also be used like E, K, and V. These are common letters that are used. So if you have, for example, two parameters or type parameters, you can have T and V separated by a comma here. Okay, so make sure you include the brackets. Here is an example. It's the same example that we've been having when we're looking at the overloading functions. Here we had a method that was displaying the elements of an array. So it was receiving an array and we were specifying the data type, that this is an array of integer, and we're displaying them. We had the integer here and we had the integer here. And the same here, this was an array of strings, so we had string here, we had string here for displaying all the elements of string. And here we are saying you can come up with a generic method that should do exactly the same regardless of the type of parameter, regardless of the type of array, the data type of the array elements. So here we have public static. Instead of a data type, we have the generic. So this is a generic or what we call a type parameter. So we have a type parameter here, then a data type. So here we had the integer. We can now use the type parameter instead of that. So we have T, and here we also have T. So this is an array of type T, and we are displaying elements of type T. So when we make a call, when this one is receiving the interface, we are going to send the type parameter as well, and that type parameter is what is going to be used instead of T here. Okay, so by writing this, it means using this method, now we can display array elements of integers or double or float or even any type of object without necessarily doing any casting whatsoever. Okay, so maybe you'd ask, how would this one be called? For the generic method, the calling is the same as you do with any other method. The way you could call this method is exactly the same way that you would do to call a generic method. the parameters that you sent will determine the type of parameter or the type of generic variable, the type parameter that should be used to replace this. It is going to inspect the arguments, and from there it will know that okay, these arguments are of the data type maybe integer, so this will be treated as an integer. Okay, erasures. As you see, when we have created a generic method like this, we do not have the data types indicated. Now the question would be, when this one maybe is compiled, what is placed here, what is placed here? So when the generic method is translated into bytecode, when we are translating or compiling our code, the type parameters are removed and they are replaced by actual types, and this process is what we call erasure. But mind you, the replacing is not that when we are sending an array of type integer. The replacing, it doesn't necessarily mean that the t will be replaced by an integer. In other languages that would be the case, but in Java it replaces those type parameters with an object of with a type of object by default. So it uses object. This ensures that there's only one copy or one version of a method. So it creates a method. Instead of t, it will put object here, and instead of t here, it's also going to put object. So it will be 4 object elements in blah blah blah, and we display. But the compiler does the casting on our behalf. It knows that okay, this is an object and we want to display elements of this one, so it will do the casting wherever necessary. So we don't necessarily explicitly cast these elements to say okay, this is an element of data type integer, it should be casted to an integer. This is done by the compiler on our behalf. So but the method is going to be translated or compiled to a bytecode, which will be using the object as a data type instead of the integer or the double or whatever we are actually trying to use to call this method. But in other cases, because we are saying this one is by default, in other cases, as we are going to see, we can put the upper bound. If you don't put the upper bound for your the type parameter, then the upper bound becomes an object. It means during erasure, the erasure process is going to remove or replace the type parameter with an object data type. But you can put an upper bound. For example, you would say, okay, I just want my generic method to be handling, for example, maybe numbers. So you would have a number class as an upper bound. So the number class is a parent for integers, double, float, etc. So it means the t's here will be replaced by a number type. So that's what we are trying to do, or to actually demonstrate by these points on this side. So what are these bounded type parameters? There may be times when you want to restrict the kinds of types that are allowed to be passed with the type parameter. As I just stated, you would want to have, for example, generic method that should be handling numbers only. So maybe they will be handling float, integers, and double, and you don't want to have different copies, maybe in a form of overloaded method to be handling integers, numbers, and float. You can use a generic method and exclude other data types and just specify those data types that are making sense, in this case the numbers. So you will use a number as the ultimate or the highest class that can be acceptable in this generic method. So that is what we call the bounded type parameter, or why we use bounded type parameters. So let's consider a scenario of comparing two objects. Of course, we'll use the same scenario of maybe bounded numbers, but we are taking a scenario where we are comparing two objects, determining which object is smaller than the other. You know, when you have objects, for the numbers, if you have int blah blah blah, you can compare numbers using greater than or equal to symbol, less than symbols. But if you have objects, you cannot compare them using the greater than or less than symbol, because the relation operators are not applicable or are not used in reference types. So the moment you create two objects, or even if those objects are created from an integer class or the double class, then you cannot use the two parameters in this case. I mean, you cannot use the reference relation operators to compare them, like greater than equal to, or less than equal to, etc. To compare two objects, Java provides a generic interface which we call comparable, and this comparable has a method called compare to. So all those classes that have got a comparison operation in them actually implement this interface. So an integer class, a double class, or all those other classes that are able to do the comparison, like a string, will have to implement comparable. Okay, so here's an example how you can use it. If you have two objects and you have object 1 and object 2, you can say object 1 dot compare to object 2. So if the comparison here, if object 1 and object 2 are the same, is going to return 0. But if object 1 is greater than object 2, then we are going to have a positive number. If object 1 is less than object 2, we are going to have a negative number. So you can use this to compare objects. But not any class will be able to do so. We can have our comparable t as the bound for our generic class, so that we are able to have only subclasses, or those classes that have got comparable interface implemented. So here we have how we use the comparable. It's a method, and this method is actually getting three parameters of the same type, t, and t, and we wanted to get a maximum of those. So it would be objects, or it would be maybe if these objects would be numbers or whatever. So we want to see if the numbers will be compared to see whether x is greater than y, or y is greater than z, or something like that. So here we should take note of how this first part also is going to be, or is being implemented. We are having t using keyword extends comparable t, and instead of maybe int max is equal to x, we are saying t max equals x, and whatever, and we have also used the t here instead of the data types to declare those parameters. So we can have our method like this. If y dot compare to max greater than blah 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 blah, or then max will be y, or if z compared to max greater than 0, then our maximum will be z. Then this one will be able to return the maximum of x, y, and z. So this is how you extend. We're going to demonstrate using an example in our IDE to see the parameters that are able to be sent to this one. See you in that video, or in the next video.